Hello, my name is Val. Today is the sixth day in my marathon where I solve LeetCode problems in PHP and make videos for you to watch my solutions. Today is the 6th of November. The daily problem is medium. And the first time in this month when the problem's topic is not strings, it is a race actually. Uh, the problem is called find if array can be sorted. We are given array of positive integer nums. Every integer is from 1 to 256. We have no more than 100 integers. Yeah, and how it can be sorted. We are allowed to swap any two adjacent. Hope I pronounce it correctly. Sorry, I'm not a native speaker, which you can tell for sure, judging from my accent. So yeah, if we can swap, we are allowed to swap any two adjacent elements if they have the same number of set bits. And this operation we are allowed to do any number of times, including 0 times. So we can keep the array as it is. And we need to return a Boolean value, true if array can be sorted, and false otherwise. So first of all, the statement is unclear. I have checked. It is asking us to check if the array can be sorted in non-decreasing order. So that's how I found out. Okay, I looked at the comments. I checked examples. So yeah, they're asking us to check if the array can be sorted in non-decreasing order. So let's look at this set bit. So basically, set bit is a 1 from a binary representation of a number. Basically, if you Google it, you will find out that it's called Hamming weight, which we can write special function to calculate. Let's do it. So there are two ways to do it. First is straightforward, convert the number into string and calculate how many characters of that string are ones. Not cool, not cool. Totally working, just not cool. We will do the opposite. Well, won't convert the string to the number to string. Instead, we will take the last bit, or as it is called, the least significant bit, and check whether it's 1 or 0. If it's 1, we will add it to the weight. If it's 0, we will not add it to the weight. Well, we still would, but 0 doesn't change the weight. And then we will shift the number by 1 bit on the right. So we are doing this while number is more than 0. And now we are extracting last bit from a number. So single ampersand in PHP means bitwise and 1 has the representation of many zeros and only 1 in the end. So basically this is going to return either 1 if the last bit of number is 1 or 0 if the last bit of number is 0. And now what we can do, here we should not forget to add this last bit to the weight. And here we will write shift number like this. So we basically throw away the last bit and move the number, move all the other bits to the right. And here we will return the weight that we got. What are we going to do now? Let's see if this function actually is working correctly. Let's apply this function to every element of our array. Element is like this. So weight is number of set bits. It's the same as Hamming weight. So what do? We just output the number and its weight and more. Let's see what do we have here. Okay, so 8, 4, and 2 have only one set bit because they are powers of 2. These numbers have 4 set bits, right? Yeah, this is 15, this is 30. Let's go here. 3 is 1, 1, 16, 8, 4, and 2 are powers of 2, so they have only one set bit. Okay, so it looks like the function is working. Now let's look at the at the at the array that we have and what we are allowed to do with it. So we are allowed to move two adjacent elements if they have the same number of set bits. So here we can move any two elements. Basically, we can move any two elements because if we want to put 8 to any position within this segment, we can do it by doing consecutive shifts and getting it to the place we want. So if we look at the array and at the number of set bits of its elements, we can see that basically for us, array is split into multiple segments. In this case, it has two segments. First segment, first three elements. Second segment, these two elements. In this case, array has one segment with one element and one segment with four elements. And basically, we can move the elements within the segment in any, we can place the elements in any order we want. And now we are asked if this type of operation will get us to the array that is sorted in non-decreasing order. So basically, if we look at this array, we can have this part written as 2, 4, 8, and this part as 15 and 30. If we look at this array, we will only have 3 at this position. We cannot move it anywhere because it doesn't have any adjacent elements with the same number of set bits. And here we can get 2, 4, 8, 16. But still, it will start with 3, then it will go with 2. So no matter how we move the elements in the second segment, we cannot sort the whole array. So now the question is, what is the condition of array to be sortable in this case? So it looks like if the maximum element of the previous segment, here is 8, is less or equal than the minimum element in the next segment, then we can sort this array. And this condition should be satisfied for all the segments. So let's do it like this. Let's calculate the weight of current segment. We start with no segment, so it's 0 because we have no elements in the array that have 0 number of set bits. And here we will compare weight of the current element with the weight of the current segment. So basically we are tracking here if we are within the same segment or not. Because if we are in the same segment, here, like here, it's too early to tell whether we can do any conclusions about the sortability of the array. What do we need to know about every segment? We need to know its maximum, and we also need to know its minimum. So in this case, we are told that array is has maximum of 2 in the 8th power, which is 256. So we can set the minimum to 256 57 and the maximum to 0. This way, yeah. So if the current element, if the element that we just got has the same weight as the current weight, it means that we are still within the current same segment. So what we can do, we can maybe update current maximum. And we also maybe can update the current minimum. That's it for calculating. And here, okay, let's here actually just output weight car. Actually, no, let's output this and see what is happening to understand. And also, we have to start the new segment here, right? So current weight is going to be the new weight. And also we need to have new maximum contenders and new minimum contenders. Since we only have one number in this segment, basically it means that we are somewhere here. And also the same with car minimum. Let's see how we are tracking the new segments. Okay. You see, we tracked non-existent segments, right? Because actually, when we started with the weight of, which is kind of not cool. Let's start with the weight of first element. And also, yeah, so let's start with really with the first segment, not with the fake segment like this, but with the first segment. And here we start like this. Let's see what changes. Okay, we got this segment, but we didn't get this segment. And here the same, we got the first segment, so we don't get the last segment. And here we didn't get this segment. We got this segment. They both have bit mask set bits of 1. This segment, it has set bits of 2, and these two numbers also have, yeah, this has set bits of 1, this has set bits of 2. So yeah, we are losing the last segment. Why it's happening? Well, because this condition, this block of code should happen also in the end of the cycle. So basically, we should duplicate what we have here, here after this for cycle. I don't like to duplicate to copy paste the code. Instead, what I like to do, I like to adjust the incoming data. I will add some number that is definitely not going to change the output, the outcome of this function. I will put the maximum possible number here to the end of the array. It doesn't change the sortability. If array is sortable, I'm adding the super huge number on the top of it. It's still sortable. And if it's not sortable, okay, it's already not sortable. I cannot break anything which is already broken. Anyway, let's see how many intervals. Oh yeah, we are catching 2 intervals here. Here we're catching 4 intervals, and here we're catching 2 intervals. So that's cool. We are catching all the intervals, but we are not making any decisions here. So here in this branch of code within this else block, we should see if this number is going to be less than this number. But in the beginning of the segment, we don't know which number is going to be. Here, 15, we get only only in the end. So what we have to do, we need to have extra memory. We need to remember not only current maximum here, but we also need to remember previous maximum. And here we should compare previous maximum with current minimum. And also we should not forget to initialize the previous maximum 0. And now we should return true in case of nothing failed here, no checks failed here. Let's see what will happen. Okay, we are returning false. Probably that's happening. Why? Because we are comparing with 0 first time. No, we aren't. So we should not, if this is the first time, because we don't have this previous maximum yet set, so we can do it like this, I guess. Let's see if it helps. No, it's not. Oh, yeah, my bad. My bad, because here we should be returning true. Sorry. Sorry, maybe we don't need this check then. Okay. Let's see. Yeah, we don't need it. You see? You need to be very attentive with these tasks. And let's try to run this code once more. It's running. Let's try to pass all the tests. Hey, we did it. Thanks for watching. If you don't agree with the approach, feel free to share your solution in the comments. Also, you can criticize me for being too stupid. I would gladly discuss this with you. And also, please subscribe to this YouTube, to our GitHub, and to anything you see fit. Thank you.